In this video I'm going to talk through one of the practice papers that Edexcel have released for their new GCSE. This is paper 3H from set 1 of the practice tests, and as I go through it I'm just going to explain the answer that I think makes the most sense to put on paper. It won't necessarily be the quickest solution, not necessarily the neatest solution, but hopefully it'll be one that I can easily explain what's going on. So the first question is a parallel lines question which is worth 4 marks. And reading through the information about the question, we've got line BBCD, which is a straight line. BA is parallel to CQ as marked with the arrows, and AP is perpendicular to BP as marked with the right angle. Angle ABC is 54 degrees, and angle ACQ is 76 degrees. So exactly as it looks on the diagram. The question is to work out the size of angle X and give reasons for the answer. Those reasons will be the way of getting 4 marks for this question. So the way I'm going to do this is looking at this angle compared to this one here. Angle BAC equals 76 degrees because alternate angles on parallel lines are equal. And then I'm going to look at what we've got here. This angle here I can work out through the triangle, 180 degrees, and then this section here will be the remainder from the 76 degrees. So next bit of reasoning is angle BAP equals 180 degrees minus 54 degrees minus 90 degrees to give us the remaining angle, which equals 36 degrees. And that's because angles in a triangle add to 180 degrees. And I've shown the working there, so I don't need to go further with that. My final step then is to say angle PAC equals 76 degrees minus 36 degrees equals 40 degrees, and that gives me my answer that X equals 40 degrees. I've explained my reasoning and I've labelled the angles that I'm using. I've also annotated the drawing, which is not particularly helpful, but it's good for me if I'm checking my answers afterwards to make sure that I've done the right thing. Question 2. Jenny's organising a party. She buys some paper plates and some plastic cups, and I'm immediately thinking that this is going to be a lowest common multiple question. Paper plates are sold in packs, 25 plates in a pack, each pack costs 78p. Plastic cups sold in packs, 35 cups in a pack, each pack costs £1.10. Jenny buys exactly the same number of plates and cups, so it is a common multiple question. And what is the least amount of money she pays? It is a lowest common multiple question, but I'm going to have to go back afterwards and calculate the cost. So she's got to buy the same number of plates and cups, so let's do lists of multiples of 25. I'm just going to go up to 200 to begin with and see if I can find a multiple of 35 that matches one of those. So I've got 35, 70, 105, 140, 175, and there's my common multiple. 175 appears in both lists. So she needs to buy 1, 2, 3, 4, 5, 6, 7 packs of cups, of plates, 7 packs of plates, and 1, 2, 3, 4, 5 packs of cups. So that is plates, and I should label with words the parts of my working to make sure that it's clear for the examiner and also for myself for checking. So plates, there are 7 packs at 78p each, so that equals 546p or £5.46. And cups we're doing 5 packs of cups at £1.10 each. So £5, £1, 5 times £1 10, which is £5.50, and add them together. And that is £10.96. So total cost £10.96. Question 3 looks like a ratio proportion question. There are only red and green beads in a bag. Red beads and green beads in a bag. The ratio of the number of red beads to the number of green beads is 5 to 9. Red, green. What fraction of the beads are red? That's 5 out of a ratio of, well, 5 to 9, which is 14 in total in that pair. So 5 out of 14 beads are red. There are a total of 84 beads in the bag. How many of the beads are green? So ratio 5 to 9, which each share is worth 14. So 84 divided by 14 equals 6. So there are 6 of these shares in the bag. 6 times 9 of them are green. 6 times 9 equals 54. So 54 green beads. And I want to check that I've got that right by looking at the other colour in the bag, which is 5 times 9. Sorry, not 5 times 9, 5 times 6, or 6 times 5 if I'm going to use the same working as I did on the line before. So 6 times 5, which is 30, and 30 and 54 add together to make 84, so I know I've got the right number of green beads there. Susie is going to put some more beads in the bag. There will still only be red beads and green beads in the bag, so I've only got the option of adding red or green beads. Susie wants to have twice as many green beads as red beads in the bag. Twice as many green beads. What beads should she put in the bag? You must explain your answer. So, at the moment she's got 30 red to 54 green, and she wants this to be twice as much as that number, so she just should increase this to 60. So we can say that Susie should put 6 green beads in the bag, so that she has 60 green beads in total, twice as many as the 30 red beads. I doubt that all of that explanation is required, but having put all of that explanation in, I feel confident that I have explained my answer and that I've got the answer correct. And it's worth 7 marks, so every bit of explanation is needed there. 7 for the whole question. Question 4. The table shows some information about the average adult spending in 2008 as a percentage of average total adult spending in 2008. So this is how the total is split into various different sections. In May 2008, Katie spent a total of £425, and she spent £48.45 of that money on food. Compare the percentage that Katie spent on food with the average adult spending on food. We can go about this in several ways. I could either find 48.45 as a percentage of 425. I think the easiest way for me is to say that 11% of 425 equals, well, my calculation is 425 times by 0.11 for 11%. So that is £46.75, which is less than the amount that Katie spends. So let's say that Katie spends more on food than the average adult. $46, $48, $45 is greater than $46, $75. So that's compared and given numbers, a numerical justification for my decision there. Question 5. Coventry Estates sells houses. In February, they sold twice as many houses as in January. In March, they sold 10 more houses than in February. In April, they sold half as many houses as in March. So this is a series of pieces of information which build on each other. I'm expecting to use some algebra in this question. Coventry Estates sold a minimum of 123 houses from 1st of January to 30th of April. So this is the whole time span represented by these months here. Find the least number of houses sold in January. We've got a minimum overall, and so least number of houses sold in January. That will fit with that. So I can set up an equation for this. As always, when setting up an equation, I only just want the one variable if I can, and then write everything else in terms of that variable. So let x be number of houses sold in January. And then month by month, I can write out my working in Jan. X houses were sold. In Feb, we've got twice as many houses as there were in January. That's 2x. In March, 10 more houses than in February. So that's 2x plus 10. And in April, they sold half as many houses as in March. So that is 2x plus 10 over 2. Which I can write immediately as x plus 5. When I add all of these together, total sales between 1st of January to 30th of April, that's at least 123 houses, minimum of. So x plus 2x plus 2x plus 10 plus April's x plus 5 is greater than or equal to 123. And then I can collect like terms here, so that's 2x, 4x, 5x, 6x, plus 15 is greater than or equal to 123. Subtract 15 from both sides, and that gives me 6x is greater than or equal to 108. Divide both sides by 6, and we get x is greater than or equal to 18. So that's telling us that if x is the number of houses sold in January, as we defined it, x is at least 18 houses. So the least number of houses sold in January is 18. I think 18 on the answer line would probably be enough for that. Question 6. The diagram shows a circle inside a semicircle. As soon as I see a picture like this, I'm going to flag up to myself that it's a semicircle, and therefore I'm going to have to half the area of the circle that I calculate. The circle has a diameter of 10 centimeters. The semicircle has a diameter of 20 centimeters. That means that this circle must be this must be the midpoint, the center of the semicircle, because if that radius of 10 centimeters fits within that space, this has to be in the center of that semicircle. Work out the area shaded, so I need to find out the area that is not within this circle, but that is within the semicircle, and then divide that area in half to find the shaded area. So, area of a circle is given by circle pi r squared. So in this case, my radii are 10 centimeters for the semicircle and a radius of 5 centimeters for the smaller circle. So semicircle area is pi times by 10 squared over 2. That's 100 pi over 2, which is 50 pi. I could use my calculator at this point to calculate that, but I'm going to leave things in terms of pi just because it's neater for my working. So the circle area is pi times 5 squared, pi r squared, which is 25 pi. So the remaining area is semicircle area minus the smaller circle area, which leaves us with 25 pi. Shaded area is half of that, so 25 pi over 2, which is 12.5 pi, which if I put that into my calculator gives me 39.2699 ... which to one decimal place is 39.3 centimeters squared. Checking the units, centimeters squared, and they're even given on the answer line, so 39.3 centimeters squared. Question 7. Ali was asked to solve the equation 6x minus 2 equals 3 brackets x plus 4 close brackets. Here is his working. Asif's answer is wrong. He's changed his name from Ali to Asif halfway through. What mistake did he make? Don't know why that's there. So the mistake he's made, if we follow the working, 6x minus 2 equals 3 brackets x plus 4. 6x minus 2 equals 3x plus 7. He's expanded the bracket, but he's done that incorrectly. So he expanded the bracket incorrectly. It's only worth 1 mark, but I'm still going to give a full explanation of knowing what it should be to show that I know what it should be. Second line should read 6x minus 2 equals 3x plus 12. And then I've shown that I know how it should have been done and that I've spotted the mistake. Question 8, a percentages question, a compound interest question. So Sam invests £5,000 at 2.8% per annum compound interest for 4 years. Work out the value of Sam's investment at the end of the 4 years. So we've got his initial £5,000, and every year it's increasing by 2.8%, which is a multiplier of 1.028. Remembering the 0, that's the part that most people are likely to forget. 1.28 would be an increase of 28%, so we have to have the 0 in there. And this is happening for 4 years, so either I multiply it by 4 times, or I just put that to the power of 4. And 5,000 times by 1.028 to the power of 4 equals 5583.962. 113. So as a pounds and pence answer, that is £5,583.96. Part 2, Andy invests £12,000 in a variable compound interest account, variable rate compound interest account. That means that the interest is going to be changing year on year. So he gets 2% for the first year, 3.5% for the second year, and 5% for the third year. Work out the value of Andy's investment at the end of the 3 years. And this isn't the interest earned, this is the investment itself. So we've got his £12,000. In the first year he earns 2%. In the second year he earns 3.5%. So multiplier of 1.035. And in the third year, 5%. So that's representing the three changes of interest over the years. So if I do that calculation, times by 1.035 times by 1.05, I get an answer of 13,301.82, which I don't have to round because it's already in pounds and pence. Question 9, an area and algebra question. A rectangular lawn has a length of 3x meters and a width of 2x meters. The lawn has a path of width 1 meter on 3 of its sides. The total area of the lawn and the path together is 100 meters squared, and now suddenly we have to prove an equation. So in order to do this, I'm going to go bit by bit through the problem. I know that the total area of lawn and path is 100 meters squared, so I need to represent that first of all. So total, what do they call it? They call it a length of 3x meters here. Let's say total length of lawn and path is 3x plus 1 plus 1. That is this total length here, which is the 3x plus 1 plus 1. Total width of lawn and path is 2x plus 1. That's this distance here, top to bottom, 2x plus 1. Area equals length times width. So that's 3x plus 2. So this equals 3x plus 2 times by 2x plus 1. And that equals 100 meters squared from the question. So I expand those brackets and I get 6x squared plus 4x plus 3x plus 2 equals 100. Collect like terms in the middle. That's 6x squared plus 7x plus 2 equals 100. I can subtract 100 from both sides because I need to end up with 0 on the right hand side. So that is minus 98 equals 0. And in that process I've collected like terms and subtracted 100. And because it's a show that question, I'm just going to add that I've subtracted 100 to make sure that my working is fully clear throughout that. It's only worth 2 marks, but still worth explaining everything to make sure that you get them. Calculate the area of the lawn, show clear algebraic working. So the area of the lawn I'm actually going to need in terms of real numbers, not just x and y, because I can solve it. I've got an equation here that can be solved. So my equation given in the question above is 6x squared plus 7x minus 98 equals 0. Because this is a calculated paper, I am going to work out this using the quadratic formula, which is x equals minus b plus or minus square root of b squared minus 4ac all over 2a. So here's my b value, there's my a value, there's my c value. Some of you may want to factorize this, and that's fine, great if you can factorize that using the AC method. I'm just going to put it straight into the formula because I think that is the approach that most people would take at this point. So we've got minus 7 plus or minus the square root of 7 squared minus 4 times by a, which is 6, times by c, which is minus 98. Remember the minus in here, otherwise we'll end up with something that you cannot square root. So 2 times 6, and x equals minus 7 plus or minus the square root of, that is then 49, plus minus times a minus is a plus, so 4 times 6 times 98 is 2352 all over 12, which equals minus 7 plus or minus root 2401 over 12. And square root of 2401 is 49. So that equals minus 7 plus or minus 49 over 12, which equals, we're only looking for the positive version of this because x has to be positive, but so we've got 49 minus 7, 42 over 12, which is 3.5. State the other version, which is minus 4 2/3, but x is negative. X has to be positive, I mean. X cannot be negative. X has to be positive. Because it's a length. So that gives us the area. We have to calculate the area of the lawn, not just solve the quadratic. So the area of the lawn is 2x times by 3x. Area equals 2 times 3.5 plus 3 times 5.5. 3.5, 3 times 3.5, 2x times 3x. And that equals 17.5 meters squared. And obviously I haven't laid that out that clearly. Should really have solved my quadratic on that side so that I could have ended up with working over here. But it does follow through stage by stage, so it should be clear enough to follow my working to the end there. Right, question 10. Complete the table of values for y equals x squared minus 4x minus 2. So when x is minus 1, that is minus 1 squared minus 4 times minus 1, which is going to be the same as plus 4 minus 2. So that is 1 plus 4 minus 2, which is 3. So 3 goes in here. And we can see that these values are symmetrical, but anyway, we'll just make sure. Second one, when x is 2, 2 squared minus 4 times 2 minus 2, that is 4 minus 8 minus 2. So that's minus 4 minus 5 minus 6 in here. And 3 I'm expecting to be minus 5 because these are symmetrical, but I will check again. So we've got 3 squared minus 4 times 3 minus 2, that is 9 minus 12, that's minus 3, minus 2 makes minus 5. 9 minus 12 minus 2 equals minus 5, as expected. On the grid, draw the graph of y equals, there should only be one y equals there, misprint, of y equals x squared minus 4x minus 2. So this is exactly what I've just found the points for. So first value is x is minus 1 and y is 3. It's there. 0 and minus 2. So that is now below the axis. 0 and minus 2. 1 and minus 5. 2 minus 6. And that reaches the bottom of the graph, the minimum point there, and from there on it's symmetrical. Let's check that final one. 5 and 3 is 5 and 3. And to actually draw the graph, I need to join those points, which is easier freehand rather than on computer, but I'll give it a go. Third time lucky. Hopefully you'll draw a smooth curve. That area may lose a mark. So try and keep your curve smooth as you draw through that. Use your graph to estimate the values of x when y equals minus 3. So y equals minus 3 on this line here. That is the line of y equals minus 3. So I can draw a straight line across there, and I'm estimating the values of x that go with that. Now if I'd drawn that properly, that would be around here. So I'd estimate at, that is 3.9, 3.8, 3.987, 3.7, and 0.1, 0.2, 0.3-ish. So 3.7, 0.3. Question 11. In a sale, normal prices are reduced by 12%. The sale price of a digital camera is £132.88. Work out the normal price of the digital camera. Well, if I'd known the normal price and I'd wanted to reduce it by 12%, I would have multiplied that by 0.88 to reduce by 12%. Just to check that, 100% minus 12% is 88%, which is 0.88. So I would have multiplied by 0.888 to get to the sale price. I know what the sale price is, so to get back to the original price, I have to do the inverse, and that is divide by 0.88. Of course, dividing by less than 1 is going to increase the value of the number, and that is 151 pounds. Question 12. 3D, probably involving trigonometry and possibly Pythagoras' theorem. The diagram shows a tetrahedron. AD is perpendicular to both AB and AC, so as drawn on the diagram with these three right angles. AB is 10 centimeters, that's the dotted line is 10 centimeters, AC is 8 centimeters, and AD is 5 centimeters. So angle BAC is 90 degrees as well. Calculate the size of angle BDC and give your answer correct to 1 decimal place. Angle BDC is this angle in here, BDC. In order to work that out, I'm going to need to calculate this length, and that length, and probably that length as well, and then use the cosine rule to find the angle that's here opposite that side. I can work these lines out, these lengths out, by using Pythagoras' theorem. So those are my first three calculations to do here. So DC is the square root of 5 squared plus 8 squared. Which is root 89. And I'm going to leave it as a surd like that, because I'm going to have to do further calculations with that, so I want it as accurate as possible. BD, this here, is the square root of 10 squared plus 5 squared. which is the square root of 125, which I can leave like that as well. And BC, this one here, third right angle triangle involved, is the square root of 10 squared plus 8 squared. So we've used all measurements here for each of the triangles. So that is the square root of 164. Now this is going to get complicated using the cosine rule. The cosine rule for lengths is a squared equals b squared plus c squared minus 2bc cos a, and that's the one that I generally remember. I can rearrange it to get the angle, which is what we're looking for, on its own. So I could use this version of the formula and substitute these values in for that, but I also can rearrange to the other version of the formula, which is cos a equals b squared plus c squared minus a squared over 2bc. So using that, the one that's important is that this side is A, because angle A and side A are opposite each other. B and C are interchangeable, so I can use the other two as B and C, but this side here, BC, that is my side A. So I've got cos A equals B squared, let's just say that that's B, root 89 squared, plus c squared, that's root 125 squared, minus a squared, root 164 squared, all over 2bc. 2 root 89 root 125. Now, of course, squaring all of these square roots is just the same as having the numbers themselves. So cos A equals 89 plus 125 minus 164 all over, and I'm going to do that calculation now, root 89 times by root 125 times by 2 is 210.9502311. I'm just going to leave the full accuracy answer from my calculator in there because I want to get my answer as accurate as possible, ready to round it to one decimal place. So cos A equals those three numbers, 89 plus 125 minus 164, divided by my previous answer, divided by that number there. Cos A equals 0.237022, etc. Rest of the numbers on my calculator. So A is cos to the minus 1 of that number, and that equals 76.2891, and again I'm going to write that down just so that in case I make a mistake with rounding, I've got the original answer from my calculator to make sure I get that mark, and then round it to correct to one decimal place is 76.3 degrees. Alright, question 13. A machine part is made by cutting a small square from the center of a large square piece of steel. The dimensions of the machine part are shown on the diagram and all measurements are in centimeters. The perimeter of the small square is 2/3 of the perimeter of the large square. Work out the length of one side of the small square. So I need to know what x plus 4 is eventually. So perimeter of small square. Again, I'm going to use words to label each part of my working. Small square is 4 lots of x plus 4. Each of those sides being x plus 4, so that expands to 4x plus 16. Large square is 4 lots of 3x plus 4, which is 12x plus 16. And we're told that the perimeter of the small square is 2/3 of the perimeter of the large square. So this is the more complicated bit to set up. 4x plus 16, which is the perimeter of the small square, is 2/3 of the perimeter of the large square, which is 12x plus 16. So I'm going to multiply both sides by 3 to get rid of that denominator there. So that gives me 12x, and 3/16 are 48, so that's 12x plus 48 equals 2 lots of 12x plus 16, now that I've got rid of that denominator, which equals 24x plus 32, and I might as well rewrite this again here. 12x plus 48 equals 24x plus 32. I'm going to subtract 12x from both sides, leaving me with 48 equals 12x plus 32. Subtract the 32 from both sides, leaving me with 16 equals 12x. Divide both sides by 12. And that gives me 1 1/3, or 1.3 recurring, you might have got there. 1.3 recurring equals x. And I haven't answered the question yet because I need to work out the length of a side of the small square, which is x plus 4. So 1 1/3 plus 4 equals 5 1/3. And that is the length of the small side of the square. Question 14. Caroline has 20 biscuits in her tin. She has 12 plain biscuits, 5 chocolate biscuits, and 3 ginger biscuits. She takes at random 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same type. So I'm going to draw a tree diagram for this to begin with. She's got 20 biscuits, 12 plus 5, that's 17, 18, 19, 20. So 3 branches for the first biscuit, biscuit 1, and biscuit 2. And so for biscuit 1, she can either have plain, or chocolate, or ginger. That's 12 out of 20, probability of 5 out of 20, and probability of 3 out of 20. This is conditional probability, and after she's taken a plain biscuit, there will only be 11 plain biscuits left out of the total of 19 left. However, there are still 5 chocolate biscuits because they haven't been taken yet. So plain, chocolate, ginger. And there would still be 3 ginger biscuits left. After she's taken a chocolate one, I haven't laid this out very nicely. I should have given more space to the first row, first set of branches. So that gives me, she's taken 1 chocolate, so there now are only 4 of the chocolates left, but there are still the original number of plains and the original number of gingers. And finally, if she takes a ginger first, she's got plain, chocolate, ginger, and that is still 12 of the plain biscuits, still 5 of the chocolate biscuits, but only 2 of the gingers as options now. Now we've got to find the probability that the 2 biscuits were not the same type. I'm actually going to take a shortcut with this and say, what if they were the same type? And then I'm going to do 1 minus the probability that they were the same type. So I'm going to look at the same type plain and plain, or the same type chocolate and chocolate, or the same type ginger and ginger. Plain plain is 12 20ths times by 11 19ths. Which is 33 95ths. Chocolate chocolate is 5 20ths times by 4 19ths. Which is actually 1 19th. And ginger ginger, which is 3 20ths times by 2 19ths. Which is 3 over 190. And then I'm going to add these three numbers together. And I'm going to call that the probability that they're the same is 33/95 plus 1/19 plus 3 over 190, and that equals 79 over 190. So probability not the same is 1 minus that. One minus 79 over 190, and that is 111 over 190. And that's the probability that she doesn't pick the same biscuits. As a decimal, that's 0.584. Fraction answer is better, so I've had to round that decimal in order to fit that there. Question 15. The diagram shows an equilateral triangle. The area of the triangle is 36 centimeters squared. Find the value of x. Give your answer correct to three significant figures. Well, I could either divide that triangle in two and use right-angled triangle trigonometry with an angle of 60 degrees in there, or I could use the rule half AB sine C is the area, which is what I'm going to do here. Because I know what this angle is, it's 60 degrees, and those are both the same, so I've got x times x as my two different sides. That's half times x times sine of 60, and the area is equal to 36 centimeters squared. So sine 60 is a half. It's root 3 over 2, sorry. Sine 60 is root 3 over 2. So that is root 3 over 4. When I've divided by over half, x squared equals 36. So x squared equals, let's divide both sides by root 3 over 4. Is 83.138, and I'm going to leave that figure on my calculator to square root both sides here. X equals, and I only have to give the positive answer here because x is obviously a positive measurement on the triangle, so I don't need to worry about plus or minus. That's 9.118028 ... and giving my answer correct to three significant figures, that is 9.12 centimeters, or x is in fact just 9.12. So that's that one complete. 16. Prove algebraically that the product of two odd numbers is always an odd number. So let my first odd number, we have to know how to set these up. First odd number, I need to show that it's an even number plus 1, so that's 2n plus 1. Second odd number, different variable, 2m plus 1, because it's a completely unrelated odd number to the first one, because they're not consecutive odd numbers, they're just two random odd numbers. So product of these two is 2n plus 1 times by 2m plus 1. That is 4mn plus 2m plus 2n plus 1. That's doing firsts, outsides, insides, and lasts. Now all of this lot can be factorized by 2, making it an even number. So that is 2mn plus m plus n plus 1 at the end, which is an even number because it's got a factor of 2, which is therefore an odd number. Question 17. A car is approaching a set of traffic lights and the traffic light turns red. It takes the car 4 seconds to slow down to a stop. That is from time 1 second to 5 seconds I can see on the graph here. Here's the speed time graph for the 5 seconds until the car stops. So presumably if this is speed, the car was travelling along at speed and put the brakes on here and stopped quickly. Work out an estimate for the distance the car travels in these 3 seconds. So in a speed time graph, the area under the graph represents distance travelled. And I'm going to estimate that using trapezia and a rectangle. So my first region that I will use is a rectangle followed by 5 trapezia. It does say the distance the car travels in the 5 seconds rather than in the 4 seconds after it presses its brake. So I need to go from there to there, and I've got finally a triangle at the end taking me down to the 5 seconds. So I need to know the values at each of these corners, so that is obviously 20. At this point, the curve itself looks like it's around 10.5. This point, the curve is around 4.5. And at this point, the curve is on 4. I've been misreading the scale. That must be 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 15, 15.5. No, not quite. 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15. Yes, so this is 10.25 in fact. And this is that would be 4.5, so 4.75. And this here is 2. And that's 0. So using those values, I've got a rectangle, which is 20 times 1. And then I've got this trapezium here. So the area of that trapezium is half of 20 plus 10.25 times 1. Area of this trapezium here is half of 10.25 plus 4.75 times 1. The area of that one is half of 4.75 plus 2 times by 1 again. And the area of the triangle here is just half the base times the height, half times 2. Equals 1. I'm going to add them all together, so to do those calculations, 20 plus 10.25 divided by 2 is 15.125. 10.25 plus 4.75 divided by 2 is 7.5. 4.75 plus 2 divided by 2 is 3.375. And half times 2 is 1, so adding all of these together, I've got 20 plus 15.125 plus 7.5 plus 3.375 plus 1, which is 47 meters. I'm just going to write a note here of what I did, add areas together. Is the answer to A an underestimate or an overestimate of the actual distance the car travels in these 5 seconds? I can see that the area of my trapezium is actually slightly bigger than the area under the curve because of the way the curve goes inwards. So it's an overestimate. Because area of the trapezia, or trapeziums, area of trapezia is greater than area under the curve. Yes, must be the final question. It is. A farmer wants to estimate the number of rabbits on his farm. On Monday he catches 120 rabbits and he puts a tag on each rabbit and then he lets the rabbits run away. On Tuesday the farmer catches 70 rabbits and 50 of these rabbits have a tag on them. Work out an estimate for the total number of rabbits on the farm. You must write down any assumptions you have made. So, 15 out of the 70 rabbits have tags when he catches them the next day. And we assume that that's the same proportion of rabbits as he tagged. So he tagged 120. So if 15 out of 70 are tagged, we have the same proportion. So 15 to get to 120. 120 divided by 15 is 8. So times 8, and do the same thing to the denominator here. 70 times 8 is 560. So estimate 560 rabbits on the farm, and let's think about some assumptions we've made. Assuming none of the tags have fallen off, firstly. And assuming that the rabbit stayed on the farm. Either tagged or untagged. And didn't move to another area. And that's the end of that paper. So I hope that's been useful. I'll try and make things neater next time so that you can see my working more clearly. I think that's taken over an hour to get through that paper. That is actually an hour and a half paper, so not surprising that it's taken longer than an hour to get through. Please put any questions you have in the comments underneath, and I'll get back to doing another paper soon.